Hi, in this module I will discuss strain transformation. Strain transformation means finding strains in nth direction at a point if the strains in two perpendicular directions at that point are specified. To find strain transformation equations, consider a point under plane state of strain, that is at point A. Strains in x direction, strain in y direction, and the shear strain between x and y directions are specified. We want to find the strain in any nth direction at point A in terms of epsilon xx, epsilon yy, and gamma xy. Let the nth direction makes an angle theta with the horizontal direction. This theta is to be measured positive in counterclockwise direction from horizontal axis. The normal strain epsilon nn along the nth direction at the point A can be found to be epsilon nn equal to epsilon xx plus epsilon yy by 2 plus epsilon xx minus epsilon yy by 2 cos 2 theta plus gamma xy by 2 sin 2 theta, and the shear strain gamma nt at point A can be written as minus epsilon xx minus epsilon yy by 2 sin 2 theta plus gamma xy by 2 cos 2 theta, gamma nt divided by 2. So we have specified normal strain epsilon nn in the nth direction at point A in terms of epsilon xx, epsilon yy, and gamma xy. Similarly, we have found the shear strain between the nth and the tth direction in terms of epsilon xx, epsilon yy, and gamma xy. Now we can find what are the maximum and minimum normal strains at a point. The maximum and minimum normal strains at a point are called as principal strains, and the directions along which normal strains act are called as principal directions. We want to find the maximum and minimum value of epsilon nn. Epsilon nn can be written as epsilon xx plus epsilon yy by 2 plus epsilon xx minus epsilon yy by 2 cos 2 theta plus gamma xy by 2 sin 2 theta. To find the maximum or minimum value of epsilon nn, we differentiate epsilon nn with respect to theta and put it equal to 0. We get epsilon xx minus epsilon yy by 2 into minus 2 sin 2 theta plus gamma xy by 2 into 2 cos 2 theta. Sin 2 theta by cos 2 theta becomes tan 2 theta equal to gamma xy divided by epsilon xx minus epsilon yy. We divide here by 2 and here also by 2. So this is the equation that give us the principal directions, that is the directions along which the maximum and minimum normal strains are acting. We designate this direction by P, that is principal direction. Now this equation is like tan 2 theta is equal to some constant, because sigma gamma xy, epsilon xx, and epsilon yy are constant. So it is tan 2 theta equal to constant. This equation has two roots. Let the two roots be theta 2 and theta 1. The two roots will be having an angle of 180 degrees between them. Therefore, we get theta 2 equal to theta 1 plus minus pi by 2. Let theta 1 corresponds to maximum principal strain, that is epsilon 1, and theta 2 corresponds to minimum principal strain epsilon 2. To find the value of epsilon 1 and epsilon 2, we have to put the angles from this equation to the epsilon and n equation. To find the value of sine to theta and cos to theta from this equation, follow this simple procedure. Draw a horizontal line with O as origin. Remember that tan to theta is equal to perpendicular upon base, and perpendicular in this case is gamma xy by 2, and the base is given by epsilon xx minus epsilon yy by 2. So we draw a perpendicular which is gamma xy by 2, and the base is epsilon xx minus epsilon yy by 2. This gives us the value of 2 theta. Similarly, we extend the hypotenuse. So this is minus gamma xy by 2, and this is epsilon xx minus epsilon yy by 2 minus. This is the hypotenuse of the right angle triangle, and it can be found as epsilon xx minus epsilon yy by 2 whole square plus gamma xy by 2 whole square root over. We call this as r. So this is also r. This angle is also 2 theta. Now out of these two angles, this might be theta 1 or theta 2. Similarly, this might be theta 1 or theta 2. We do not know at this stage which is theta 1 and which is theta 2. So we will obtain two solutions, one from triangle OAB and other from triangle OA''B'. Then we will put these two solutions in the equation of epsilon and n. The angle which gives larger value of epsilon and n will correspond to theta 1, and the other will be corresponding to theta 2. So the first set is from triangle OAB. From triangle OAB, sine to theta can be written as perpendicular upon hypotenuse, which is gamma xy by 2r, and cos to theta can be written as epsilon xx minus epsilon yy by 2r. Similarly, from triangle OA' and B', we can write sine to theta equal to minus gamma xy by 2r, and cos to theta is equal to epsilon xx minus epsilon yy minus by 2r. Now we will first put this set of solution in the equation of epsilon and n and find the value of normal strain. Normal strain epsilon and n is equal to epsilon xx plus epsilon yy by 2 plus epsilon xx minus epsilon yy by 2 into cos to theta. Cos to theta is epsilon xx minus epsilon yy by 2r. So it is epsilon xx minus epsilon yy by 2r plus gamma xy by 2 into sine to theta, and sine to theta is gamma xy by 2r into gamma xy by 2r. Simplifying, we get epsilon xx plus epsilon yy by 2 plus epsilon xx minus epsilon yy by 2 whole square plus gamma xy by 2 whole square whole divided by r is equal to, now putting the value of r in this equation, we found that r is equal to epsilon xx minus epsilon yy by 2 whole square plus gamma xy by 2 whole square root. So we get epsilon nn as epsilon xx plus epsilon yy by 2 plus root of epsilon xx minus epsilon yy by 2 whole square plus gamma xy by 2 whole square. So this is one value of epsilon nn that we have obtained. At present we do not know whether this value of epsilon nn is epsilon 1 or epsilon 2. So we find epsilon nn from the second set of solution, that is this set of solution. So again epsilon nn is equal to epsilon xx plus epsilon yy by 2 plus epsilon xx minus epsilon yy by 2 into cos 2 theta, which is minus epsilon xx minus epsilon yy by 2r plus gamma xy by 2 into minus gamma xy by 2r. Simplifying, we get epsilon nn as equal to epsilon xx plus epsilon yy by 2 minus can be taken out, this is minus and this is also minus, it can be taken out. We get minus epsilon xx minus epsilon yy by 2 whole square plus gamma xy by 2 whole square divided by r. Putting the value of r, we can get epsilon nn as equal to epsilon xx plus epsilon yy by 2 minus epsilon xx minus epsilon yy by 2 plus gamma xy by 2 whole square root. So this is another value of epsilon nn. Now out of these two values, it can be clearly seen that we have a minus sign in this equation, but in this equation of epsilon nn we have a plus sign. So out of these two, this epsilon nn is greater, so we designate this by epsilon 1 and we designate this epsilon nn by epsilon 2. So we have found principal strains in terms of epsilon xx and epsilon yy and gamma xy, and the principal directions are given by tan to theta equal to gamma xy by epsilon xx minus epsilon yy, and the principal directions are theta 2, theta 1, and they are perpendicular to each other. That is, principal directions are orthogonal to each other at a point. Now we will find the maximum shear strain at a point, that is, we want to find the maximum value of gamma nt at a point. Gamma nt can be written as minus epsilon xx minus epsilon yy by 2 into sin 2 theta plus gamma xy by 2 into cos 2 theta gamma nt divided by 2. To find the maximum or minimum value, we differentiate this with respect to theta and put it equal to 0. We will get minus epsilon xx minus epsilon yy by 2 into 2 cos 2 theta minus gamma xy by 2 into 2 sin 2 theta. So we get sin 2 theta by cos 2 theta as tan 2 theta equal to epsilon xx minus epsilon yy whole divided by gamma xy. So these are the angles that will give us the maximum shear strain. We can find the value of sin 2 theta and cos 2 theta from this equation and put it in the equation of gamma nt to get the maximum value of gamma nt. Doing this will give us the maximum value of shear strain at a point as gamma max equal to under root of epsilon xx minus epsilon yy by 2 whole square plus gamma xy by 2 whole square. So this will be gamma max by 2. So we have found the maximum and minimum normal strains at a point and the maximum shear strain at a point. Now we want to find what is the value of the shear strain on principal directions. Remember that principal directions are 1 and 2. So we want to find shear strain, that is gamma, on principal directions, that is 1 and 2. 1 and 2 are mutually perpendicular to each other, as we have seen. Now gamma nt at a point is given by minus epsilon xx minus epsilon yy by 2 into sine 2 theta plus gamma xy by 2 into cos 2 theta. This is gamma nt by 2. So to find the value of gamma 1, 2, we have to put the value of sine 2 theta and cos 2 theta from the equation of principal direction. From the equation of principal direction, we had obtained that sine 2 theta is equal to gamma xy by 2r and cos 2 theta is equal to epsilon xx minus epsilon yy by 2r, as we have seen here. Sine 2 theta is gamma xy by 2r and cos 2 theta is epsilon xx minus epsilon yy by 2r. So putting these values in the equation of gamma nt, we will get gamma 1, 2 minus epsilon xx minus epsilon yy by 2. Sine 2 theta was gamma xy by 2r plus gamma xy by 2 into cos 2 theta was epsilon xx minus epsilon yy by 2r. So we can see that these two terms are cancelling each other. So we get gamma 1, 2 as equal to 0. That is, there is no shear strain on principal directions. That is, the principal directions 1 and 2, which are perpendicular to each other before deformation, will also remain perpendicular to each other after deformation. So we have concluded the following points about principal strains and principal directions. The maximum and minimum values of normal strain at a point are called principal strains. The directions along which principal strains act are called as principal directions. There are two principal directions, theta 1 and theta 2. At any point, principal directions are orthogonal. That is, theta 1 and theta 2 are having an angle of 90 degrees between them. At any point, shear strain on principal direction is 0. That is, gamma 1, 2 is 0. Now, to understand strain rosettes, we have to first know about strain gauges. A strain gauge is an instrument that measures the value of strain at a point. It is a very small device that covers very small area. So strain gauge is basically used to measure the strain at a point. Strain gauges measure only the value of normal strain at a point. They do not measure shear strains. So it is to be remembered that strain gauges will measure only normal strain at a point. They do not measure shear strains. Now let us understand the working of strain gauges. A strain gauge is a small device that can be bonded to the surface of a body at point where strains are to be measured. Like this. This is the body. On this body, suppose strain is to be measured at the point A. Then we will bond a strain gauge at point A, like this. The strain gauge consists of very fine electrical wires. When body is deformed, that is, when the length of the body changes, electrical resistance of wires also changes. That changes the current values. These changes can be calibrated to deformation in the body. That is, by noting the changes in current, we can find the changes in the length of the body. in order to measure principal strains on the surface of engineering components, the technique involves the bonding of a combination of 3 strain gauges at the point under consideration on the surface. The combinations of 3 strain gauges are called strain rosettes. So, if you want to measure principal strain at a point on the surface, then you need 3 strain gauges. The 3 strain gauges can be attached at a point in various combinations. These various combinations are called as strain rosettes. This gives the value of strain in 3 known directions. Because we have installed 3 strain gauges, we will get the values of 3 normal strains, and these 3 normal strain values help us to calculate the values of principal strain or strain in any nth direction at a point. We know that epsilon nn is given by epsilon xx minus epsilon yy by 2 plus epsilon xx minus epsilon yy by 2 into cos 2 theta plus gamma xy by 2 into sin 2 theta, and gamma nt by 2 is given by minus epsilon xx minus epsilon yy by 2 into sin 2 theta plus gamma xy by 2 into cos 2 theta. Now, to find the value of epsilon nn, that is strain along any nth direction at a point, we need epsilon xx, epsilon yy and gamma xy. Now, epsilon xx can be directly given by the strain gauge along x direction. Epsilon yy can directly be given by strain gauge along y-th direction. But remember that strain gauges do not measure shear strain. So, strain gauges will not give us the value of gamma xy at point. To find the value of gamma xy, we have used another strain gauge. That strain gauge will give us the value of epsilon nn in some known direction. Now, by putting the value of that known direction, that is theta, in this equation and the value of epsilon nn that is obtained from strain gauge, we can find out the value of gamma xy from this equation, because we already know epsilon xx, epsilon yy from the 2 other strain gauges. So, using 3 strain gauges, we can find epsilon xx, epsilon yy and gamma xy. Now, since we have find the value of epsilon xx, epsilon yy and gamma xy, we can now find the value of epsilon nn, that is strain along any nth direction, by simply putting the value of angle theta. And the shear strain can also be measured at that point by putting the value of epsilon xx, epsilon yy and gamma xy. Therefore, to completely obtain the strain in any nth direction at this point, we need to install at least 3 strain gauges at this point, that is, one along some direction, one along some direction and the third one along some direction. These 3 strain gauges will give us the values of 3 normal strains at a point. Now, using 3 normal strains at a point, we can obtain gamma xy also, and once we have obtained gamma xy, epsilon xx and epsilon yy, we can obtain normal strain along any direction and also the shear strain along any direction at the point A. So, we need minimum 3 strain gauges at a point to completely find the strains at that point. So, depending on how the 3 strain gauges are installed, there are different kinds of strain rosettes. For example, 45-degree strain rosette. In 45-degree strain rosette, the strain gauges are installed one along x-th direction, one along y-th direction, and the third one is along an angle of 45 degree to x-th and 45 degree to y-th. Now, this will give us epsilon xx, this will give us epsilon yy, and this will give us epsilon 45 degree. Remember that theta is to be measured from horizontal direction, positive in counterclockwise direction. So theta here is 45 degrees. We have learned that epsilon nn is equal to epsilon xx plus epsilon yy by 2 plus epsilon xx minus epsilon yy by 2 into cos 2 theta plus gamma xy by 2 into sin 2 theta. So from the strain gauge A we can get epsilon xx, from strain gauge B we can get epsilon yy, and from strain gauge C, that is this strain gauge, we can get epsilon 45. Now we put the value of epsilon 45 in this equation, and theta is equal to 45 degree, and we already know epsilon xx and epsilon yy. We can get the value of gamma xy. So now in this equation we know the value of epsilon xx, epsilon yy as well as gamma xy. So therefore we can find the value of normal strain at this point by simply putting the value of theta. Suppose we want to find the normal strain along this direction, that makes an angle of 50 degrees with the horizontal axis, then we can get the value of normal strain at this point by putting theta equal to 50 degrees. Similarly, gamma nt can also be obtained because we know epsilon xx and we also know gamma xy. So putting these three values we can also obtain gamma nt. Therefore, by using three strain gauges A, B and C, we can find out the normal strain as well as shear strain at point in any direction. The other strain gauge is 60 degree strain rosette. In 60 degree strain rosette, one strain gauge is A along xz direction, one along this direction and one along this direction. This is B, this is C. This angle is 60 degree, this angle is also 60 degree, and this angle is also 60 degree. So we can use epsilon nn is equal to epsilon xx plus epsilon yy by 2 plus epsilon xx minus epsilon yy by 2 into cos 2 theta plus gamma xy by 2 into sin 2 theta. Now epsilon A will give us epsilon xx and this will give us epsilon 60 degrees. This is theta B. So we can put epsilon 60 degree is equal to epsilon A plus epsilon y by 2 plus epsilon A minus epsilon y by 2 into cos 2 theta B plus gamma xy by 2 into sin 2 theta B. Similarly, for strain gauge C, we measure angle theta C. Note that angle is measured from the horizontal direction and positive in counterclockwise direction. So this is theta C and it is equal to 120 degrees. So we get epsilon 120 is equal to epsilon A plus epsilon y by 2 plus epsilon A minus epsilon yy by 2 into cos 2 theta C plus gamma xy by 2 into sin 2 theta C. So now we have two equations, this and this, and we have two variables epsilon yy and gamma xy. Using these two equations we can find gamma xy and epsilon yy. And once we have obtained epsilon xx, epsilon yy and gamma xy, that is this as well as this, then we can find out normal strain epsilon nn at this point by simply putting the value of theta of the direction along which we want to measure the normal strain. Similarly, we can also find strain gamma nt at that point, because we know epsilon xx, we know epsilon yy, and we also know gamma xy. Another strain gauge can be 120-degree strain gauge, in which one strain gauge is put like this, another like this, and another like this, making an angle of 120 degrees between each other. So we call this strain gauge as A, this is B, and this as C. Strain gauge A will give us epsilon A, strain gauge B will give us epsilon B, and strain gauge C will give us epsilon C. Remember that theta is to be measured from horizontal, positive in counterclockwise direction. Therefore, this epsilon A will be given by theta A, and theta A here is equal to 90 degrees, and theta B is equal to this angle. So theta B is equal to 90 plus 120, that is this 120 from here to here, and 90. And epsilon C again, it has to be measured from horizontal, positive in counterclockwise direction, that is this angle will be theta C. So theta C will be equal to 90 plus 120 plus another 120. So it is equal to 330 degrees. Now we have three equations. One will be epsilon A theta A, another will be epsilon B theta B, and other will be epsilon C theta C. So from these three equations we can find out epsilon xx, epsilon yy, and gamma xy. Once we have obtained these values, we can find out the value of epsilon nn and gamma nt at this point by using these values. This ends this module. Thank you.